Yes. Hello students. Today we are going to start with our first chapter, that is the introduction part. And this chapter, the main contents of this chapter includes, first one is the electrical energy sources, then organization of power sector in India, then single line diagram of thermal, hydro and nuclear power stations, and then the classification of power plants in base load and peak load plants. Okay, so these are the various contents which we have to cover in the first chapter. So starting with the various electrical energy sources. So what are the various types of electrical energy sources? Like there is the coal. Coal plants are thermal plants, which includes the main source for the thermal plant is coal. And like the main source for the hydropower plant is the water. Okay. And for the nuclear power plants, the main source is uranium. Okay. And diesel plants are also used, where the diesel is used as the main source. Then biogas plants are there, biomass is used. Okay, so the various sources for producing the electrical energy are coal, oil and natural gas, fossil fuels, steam, biomass, nuclear की category में there is the uranium, and wind, solar and water. Okay, so these are the various sources for producing the electrical energy. And see here this circular graph, and from this we have concluded that the major category of the power plant is the coal power plants. So almost 53.3% is the coal power plants, and then about 10% are the gas power plants, then about 0.9% are the oil power plants, in which includes the diesel power plants, and 24.7% includes the hydropower plants, and about 2.9% includes the nuclear power plants, and then is the renewable energy sources for 7.7%. So these are the various electrical energy sources. And these are the different coal power plants in our country. So the main are the in Chandrapur in Maharashtra, then Naveli Lignite Corporation Limited, and then Vindhyachal, Korba, then Ramagundam, all under the NTPC. Okay. So this is for the Durgapur, Maharashtra, having capacity of 2,340, and Naveli plant is in the Tamil Nadu with the capacity of 2,280 megawatt. Okay, and this Vindhyachal and NTPC. So this comes under the Madhya Pradesh, having the capacity of 2,260 megawatts. And this Korba STPC, NTPC के अंदर ही आता है. So in Chhattisgarh, this having the capacity of 2,100 megawatt. And similarly in Ramagundam, NTPC के अंदर ही है. So in Andhra Pradesh, this plant also has a capacity of 2,100 megawatt. So these are some of the main high capacity power plants. And these are the various locations where the hydroelectric power plants are located. Okay, like in Punjab, if we talk about, so there the main power plant is the Bhakhra in Bhakhra Beas Management Board. So Bhakhra mein hai. So and there is the Pong Dam is there. Okay, there on this is on the Yamuna tributary. Okay, Tehri Dam is there. Okay, Rana Pratap Sagar Dam is there. Jawahar Sagar, Gandhi Sagar. Okay, so these are the various locations all over India where the hydro projects are there. And this is our next topic, that is the different organizations of power sector in India. So all the organizations that are related to the power sector, maybe it is a organization with the hydro plants, with the thermal plants, or with the nuclear plants, or any corporation that deals with the transmission and distribution of electricity in the city. So that you can write. So here there is a long list. That is the first one is the Damodar Valley Corporation, DVC, and it is established in the year 1948, and this is for the generation, transmission and distribution in the specified region. Next one is the Bhakhra Beas Management Board, BBMB, and it is established in the 1967, It is for the administration, operation and maintenance of projects under the board. That all the projects that comes under the Bhakra Vyas Management Board are handled by this BBMB. Next is the Rural Electrification Corporation, REC. So it is established in 1969 and it deals with the financing and implementing rural electrification schemes, mainly in the villages or rural areas. Okay, next one is the National Thermal Power Corporation, okay, NTPC, and it is established in 1975 and it deals with the thermal plants, the concept to commission and operation of power plants. Next is the National Hydroelectric Power Corporation, okay, NHPC, and it is established in 1975. So it deals with the hydro plants, concept to commission and operation. And next is the Northeastern Electric Power Corporation, NEEPCO. Okay, and it is established in the year 1976. And it deals with the developing the power projects in the northeastern region of the country, like in the Assam, Meghalaya, Mizoram, Sikkim, in that northeastern states. So that is deal with by the Northeastern Electric Power Corporation. Next is the Power Finance Corporation, PFC. It is established in 1986. So it deals with the financing of power development schemes, that where the development is required. Okay, so that it deals with that Power Finance Corporation. So next is the Tehri Hydro Development Corporation, THDC. It is established in 1988. It is the development of hydro potential in the specific river valley. Next is the Satluj Jal Vidyut Nigam. Okay, it is established in 1988 and it deals with the development of hydro potential in the specific basin. And next is the Power Grid, that is, you all know, with the Power Grid Corporation of India Limited. So its stations are in the all over India. Okay, and it generally comes under the central government, and it is established in the 1989 and it deals with the transmission system for evacuation of the central sector power and establishment operation of inter-regional grids, load dispatch centers. Okay, it relates or it deals with the that how much electricity is fed to that any particular area in the whole country. And next is the Bureau of Energy Efficiency, BEE, and it commences in 2002, responsible for spearheading the improvement of energy efficiency of economy through regulatory and promotional instruments. That matlab how the energy consumption is reduced or how the cost factor is reduced by improving the devices or by improving the machinery. Okay, so it all deals with the energy efficiency. And now next is the single line diagram of thermal power plant. Okay, so this is the detailed single line diagram for the thermal power plant. And in this diagram, we have to start with this, the central portion is the boiler. And what is the input to the boiler? That is the coal input. Coal storage is there. Then coal handling plants are there, and that is the boiler. And after boiler, when the coal is burned out, it removes the ash. And then there are the ash handling plants and ash storage, and then ash is stored in some open areas. Okay. And then this, from this boiler, the heat steam is fed to the superheater, and where that steam is again heated to its superheated value, and then that superheated steam is fed through this valve to the turbine. And with that high pressure steam, the turbine starts rotating, and this turbine is coupled with the alternator on the same shaft, and with the help of this alternator, the electricity is produced. Okay, the electricity is produced and it is then step up by the transformer and then shifted to the bus bars. And other blocks are there, like economizer is there, air preheater is there. Air preheater means the air that is fed to the boiler for the heating purpose. Okay, that is already heated air by using here the air preheater. Okay, which is connected with the forced draught fan. So it sucks the air from the atmosphere and then it is heated in the air preheater and then it is fed to the boiler. Okay, and from it is also included with the chimney, and from this chimney the extra exhaust gases are left out to the atmosphere. And then on this side there is the turbine. The extra steam from the turbine is condensed in the condenser, where the cold water is taken from the river or some cooling towers are there. The water is circulated in the condenser, which condensed the exhaust steam from the turbine, and that condensed steam is again fed to the boiler. Okay, so this is all about the single line diagram of the thermal power plants. So the various blocks and the various parts for the thermal power plants. And next one is the single line diagram for the hydropower plants. And in case of hydropower plants, we know the different parts. The first one is the reservoir, where the water is collected from the main river. Then dam is there. Okay, then here is the trash rack. So the function of the trash rack is just to remove the unwanted particles. That unwanted particles like big rocks are there, or some dust particles, or some any, that should not enter the penstock. So that are stopped here, and trash rack is there. Then surge tank is there. The surge tank is to control the pressure in the penstock, pressure of water. Okay, so the surge extra water is fed to the surge tank, so that the pressure inside the penstock should not be go beyond the limit. Then the valve house is there. Then these are the some anchor blocks are there. Then from penstock, the water is fed to the turbine. And here the turbine used is the vertical turbines are there. Like in the thermal power plants, they are generally use the horizontal turbines, but in case of the hydropower plants, there we use the vertical turbines. And when the water is fell upon these turbines, it starts rotating, and it is connected with the main same shaft with the alternator, and the electricity is produced. Okay, and the extra water is fed to the tail through tail race to the river again. And sometimes their pump is installed. Sometimes in some power plants the pump is there, which can again pump this water to the reservoir. Okay, because we know that hydropower plants are comes under the different categories, and in case of the pump storage hydropower plants, so this the water coming from the tail race is again pumped back to the reservoir. Okay, and similarly the water is circulated, and this happens generally when there is no rainfall. Okay, then we generally use the pump storage hydropower plants. That same water is circulated again and again through the power plant. Okay, so this is the main block diagram for the hydropower plants, and these power plants are generally installed in the hilly areas. Okay, generally installed in the hilly areas. So this is the another figure for the hydropower plants, and the same parts are there also. The reservoir, dam is there. Okay, here is the trash rack is there, control gate. Then there's the penstock, and when the water comes from the penstock, it rotates the turbine, and turbine is connected with the generator, alternator, and which is further connected with. So this is the another view for the hydropower plant. And now the next one is the single line diagram of the nuclear power plants. So, and in the nuclear power plants, the main parts are like control rods are there. So main is the reactor is there. So this is the reactor. in which the control rods are there, which can control the fission process inside the reactor. Okay, and from here the high steam, high temperature and high pressure steam is fed through this steam generator, and through this the steam is moved to the turbine, which moves the turbine, which is connected with the generator, and the production of electricity is there. And this is the condenser is also there, through which the cold water is circulated to condense the hot steam, and which is again connected with the reactor. Okay, so this is a single line diagram for the nuclear power plant. And this is the list of the various nuclear power plants in India. Like it is there in the Tarapur, Maharashtra is there, having the capacity of 160 megawatt. And it is started in 1964, then 1969 date critical, then start power in 1969. Okay, then there is the Rawat Bhatta, Rajasthan. Rawat Bhatta, Rajasthan is there. Then Kalpakam, Tamil Nadu. Then in Narora, Uttar Pradesh. Then in Kakrapara, Gujarat. Okay, then in Karwar, Karnataka. Okay, then in Kota, Rajasthan. And in the Tarapur, again, Maharashtra. So these are the various locations where the nuclear power plants are there in India. Now next is the classification of power plants as a base load and peak load plants. So what is the base load? That is continuously working for 24 hours. Okay, for 24 hours or continuously for 1 week or for 1 month or for 1 year. So that are called as the base load plant. And the peak loads are which when the load is increased in particular duration of time. Okay, so that is the peak load. Okay, and in that peak load, some plants are there which can be easily start up. So that plants are used for the peak load plants. And now the requirements for the plant supplying the base load. The first requirement is the minimum operation cost. Next is a continuous supply of load. Okay, the plants which are worked under the base load plants should be such that they can be able to supply or they can be able to work continuously, okay, for the long duration of time. Next, the capital cost of the plant should be minimum. The requirement of plant maintenance should be minimum. Okay, they plants don't need more maintenance. Okay, they are continuously working smoothly. Plant should be such that it can be easily located near the load center. The number of operators required should be minimum, and the spare parts should be readily available. So these are the main requirements for the power plant that work as a base load plant. And under this category, the different plants like hydro plants are there. So for the hydro plant, its operating cost is minimum, because what is the main source for the hydro plant? That is the water, and that is naturally available. So its operating cost is minimum. And next is maintenance cost is also very less. Then its initial cost is high. The hydropower plants are in such category that has the very high initial cost out of all the power plants. इसकी जो capital cost होती है तो that is very much high, and it can't be located near to the road. It is always located in the hilly areas where there is some river flow is there. Okay, like, and for the next steam power plants, its capital cost is more. It can be located near to the load center, and its maintenance requirement is slightly higher. It needs maintenance. Okay. Next is the diesel power plants. Due to the limited generating capacity, it is not used as a base load plants. Diesel power plants, its fuel cost is very high, but its generation capacity is very low. Okay, so this is the main reason that it is not used as a base load plant. Next is a nuclear power plant. Its initial cost is high because it's the fuel, that uranium. The uranium that is used as a fuel is very much costly. Okay, so its initial cost is high. limited availability of fuel. Okay. Then whenever they are constructed, they are used as a baseload plants due to the constant supply. But in the areas where the nuclear power plants are there, it can be used as a baseload plant. But the number of nuclear power plants are very less in our country. Okay? But where they are installed, they are used as a baseload plants. Now the requirements for the plant supplying the peak load plant. So for the peak load, low operating cost, minimum capital cost must be there. The plant should be capable of being started from cold condition within a minimum time. So this is the main requirement. This number 3, this is the main requirement for the peak load power plants, that the plant should be capable of being started from the cold conditions within a minimum time. Cold conditions mean the off condition. Whenever the peak load is there, whenever there is emergency, whenever the load is increased, these plants should start up at once. Okay, within a no time. Okay, so these plants are generally used for the peak load plants. And in case of emergency, the plants should have the capacity to withstand the peak load for some time. Okay, so here the word used is some time, that is for a short duration of time, not for the long duration of time, because these type of plants should not work for the long duration of time. They just work for some hours, like for 2 hours or for 5 hours or for 6 hours, that's it. They have the low capacity. And it must have quick response to the change in load. So it can handle the change in load. Whenever the load is increasing or whenever the load is decreasing, the switching on and off is quick in these type of plants. And under this, like in case of hydroelectric power plants, it can be considered as a peak load plant. It can be easily started and no fuel required. So some of the hydropower plants, just the small level hydropower plants like pump storage type or low head hydropower plants are generally used as a peak load power plants. Okay, so the hydropower plant is capable to be used both as a base load as well as for the peak load plants. It is feasible for both. Okay, and for next is the nuclear power plants. They are not used as a peak load plants because it takes time to start up. It takes time to heat up. So this is the main reason that nuclear power plants are not used as the for the peak load power plants. Next is the diesel power plants. So these are the best suitable for the peak load power plants, and because easily start from the cold conditions, and the number of auxiliaries required is limited, so less maintenance is there. They have good overload capacity. They have high thermal efficiency, therefore less operating cost than the steam power plants. Okay. So generally the power plant that is used as a peak load power plant are the diesel power plants. So these are the topics that comes under this first chapter, like introductions. Okay, then the different organizations of power sector in India. Okay, then single line diagrams, then this base load and peak load power plants. So under this first chapter, we have covered these 3-4 topics, like the electrical energy sources, the first topic. And then there is the organization of power sector in India. I'll just show you the various topics. So these are the different topics that we have covered. Electrical energy sources, organization of power sector in India, then the single line diagram of the thermal, hydro and nuclear power stations, and then the classification of power plants in the base load and peak load plants category. Okay, so this is all about our first chapter. Yes.